Let's move on by discussing IPv4 configuration and various network settings. So, we need to cover how the system sets up networking for its interface or interfaces. And to do so, we'll take you to the shell. Let's close one of these extra shells and navigate to this shell here. We'll focus on our local system, so let's close the window to the remote host and give you a sense for how the system boots up and provides networking services. So the system comes up in a multi-user mode, such as 3 or 5, and in doing so, it loads network support. So let's just label this network support. So you boot your system into a multi-user mode, and the system knows, the operating system that is, knows to provide support for your networking interfaces. But how does it know that there is an ETH0 interface? Well, the kernel has to load a driver or a module which provides support for that Ethernet interface. There's a file in etc known as modprobe.conf. If we examine the contents of this file, we see aliases for various devices connected to the machine. But in particular, we see the alias for ETH0. And if your system has more than one interface, such as ETH1, 2, and 3, you'll see the aliases in etc modprobe.conf. So, etc modprobe.conf contains alias and reference to module or modules to be loaded in order to provide networking. Providing the module listed in the document or modprobe.conf loads successfully. In this case, it's the E100 module. It's assigned the alias ETH0. And that is where, when we execute ifconfig, ETH0 comes from. But ETH0 is an Ethernet interface which can be configured with a variety of protocols, such as IP version 4, version 6, among others. So the interface, in effect, has to be configured. Additionally, a determination needs to be made whether or not the interface is to be configured statically or dynamically. So with that said, once a module has been loaded, Linux decides if the interface is DHCP or static, or perhaps even bootp, but you're more likely to see DHCP and static interfaces. So either dynamic or static. This determination is made by the following file. If you navigate into etc system, or sysconfig that is, and examine the contents of this directory, you'll see files controlling all aspects of the system, from the keyboard to syslog, DHCPD, startup, and the key directories that are of interest include networking and network-scripts. In network-scripts, you will find, let's navigate into it, various scripts that support the invocation as well as devocation or downing of interfaces. So you'll find a series of if-up and if-down scripts, as well as an interface configuration script for your loopback as well as Ethernet interface. So let's get this path and paste it into our documentation. So Linux decides if the interface is DHCP or static by viewing the contents of this directory, and in the case of ETH0, the primary or first Ethernet interface, ifconfig-eth0. In addition, another file is read, so let's indicate the list of files. We'll put this as second because it brings it up. In etc sysconfig, there's a network file. Let's take a look here, one level up. This network file is also consulted. If we cat the contents of it, you'll see that it includes that networking is to be enabled, whether or not IPv6 support is supposed to be enabled, the host name, and the gateway assigned to the interface or to the system, the default gateway. So this is read for networking equals yes or no, IPv6 support, default gateway, amongst other settings. So once that's read and a yes has been determined for networking, the interface has to be brought up. It needs to be configured, and that leads us back to the network-scripts directory. And in here we find different if up and if down scripts. So contains if up, if down, and if config scripts, of which you'll find if config eth0. Now, when is this if config eth0 consulted by the if up command? In this particular case, if up for the protocol that we intend to assign to the interface. Well, that's a good question. This if up script is consulted by the startup environment. What is the startup environment? Well, again, supposing we are booting into a multi-user level and the driver has loaded, Linux needs to decide whether or not networking is supported and whether or not static DHCP settings are to be assigned. But when the services are coming up, regardless of distribution, the following file is consulted, etc init.d network. This is the main service for networking regardless of protocol to be assigned. So a brief look at etc init.d network reveals or provides a window into the environment that's defined when a system starts. It includes reference to the source function library, which provides support for notifying processes of networking support, amongst other things. Then it checks whether or not etc sysconfig network exists. That's the step we just mentioned. The network file is consulted to see whether or not networking support is to be enabled. So a check is made for this file. If it's found, then the contents of the file are incorporated into the overall network script startup. Another check is made for PCMCIA in the event that Red Hat Enterprise is installed on a laptop that makes use of a PCMCIA Ethernet interface adapter. If it doesn't exist, that's not a problem. The network script continues. If networking is equal to no, then in this particular case, it'll exit with a 0 status and will not provide networking support. A search is made for the IP utility, which helps with assigning via the ifup script IP addresses to the interface. If IPX is required, IPX internal net is also consulted, but that's not the case. If VLANs are configured, which is supported by the Linux kernel, then this utility is required, the vconfig utility. And then additional networking functions are sourced. And enumeration is made beneath network functions for different ifconfig utilities, or scripts that is, including eth0. Now we see a case if we are in start mode, which the system is in when it's coming up, this case is executed. So we see if networking IPv6 is yes, which is derived from the original etc sysconfig network file, then the following init script is referenced to set up IPv6 support, which automatically contacts IPv6 providers such as your default router and configures IPv6. Again, if networking is yes, the loopback interface is brought up, and that's where ifup is executed against the ifconfig-loopback adapter file. We can look at this remote system. The files are identical while we discuss the references that are being made here. So if networking is set to yes, ifup ensures that the IPv6 script, the global script, is executed, It also ensures that the loopback adapter is brought up, so IFUP processes the loopback adapter script, which contains, as expected, a reference to the device, its IP address, the net mask, which is set to 8 bits, the network, the fact that it is to be brought up on boot, its broadcast, and its name, which is loopback, which is where the name comes from when we execute ifconfig. LO is equal to loopback with the address that you see here. The parameters that are set here are all configured in this ifconfig loopback adapter file. And you see it. The mask, 8 bits. The address, .1. The device is loopback. Its name is loopback. So IFUP processes the items here and sets up this virtual loopback interface. Now back to our case where networking is set to yes. Now we see below a case for IPX, which is nested within the case to start the interface. If IPX support is to be assigned to the interface, then the following IPX_configure will be configured and IPX support will be provided. If VLAN support is enabled, then the VLAN utility will be referenced. It's 8021Q, and it will be configured. And if you keep searching through, you'll see the interfaces that are brought up. A search is made for the ifconfig files, which will eventually load support for ETH0, and that's what sets up the ETH0 environment. But enough of the nitty-gritty. The flow is as follows. You boot your system into multi-user mode, meaning non-single user, non-shut, non-reboot modes. etcmodprobe.conf is referenced by the kernel to provide modular support for your network interface or interfaces. The operating system checks the etc sysconfig network file to determine whether or not networking is to be supported, and it also needs to make the determination as to whether or not the address assignment will be handled automatically or statically, so dynamically or statically. Once that determination has been made by processing the network script's ifconfig interfaces file, such as ETH0, and setting up a loopback adapter, the networking interface is available. Now once you're up and running, you can use service network status to determine the current status of networking. So this checks networking and tells you if it's running, and you may also use service network status to restart as well as stop interfaces. This tells us the list of configured devices and the active devices, loopback and ETH0. That's what you get when you execute service network status on the local as well as on the remote system. The service script is a wrapper script provided by Red Hat, which references items in the etc_init.d directory, which return useful information depending on the option passed, such as start, stop, restart, reload, status, and so on. So we know that networking is up and running, and ifconfig tells us that the interface is up and running. But how do we go about making changes to the interface? Supposing we wanted to, let's say, add another IP address or 2 or 3, or even just make general changes. Well, there are multiple tools. For example, systemconfig network, and depending on the option or the version that you'd like, so we'll just indicate asterisk, we'll launch a GUI or text-based application which allows you to make changes to your networking interfaces. So network interface configuration. With that said, let's launch one of the tools on our local system by executing systemconfig network. We'll tab it out, and there you see multiple options. We've got network, network GUI, text user interface, and a command line utility. The command line utility by default enumerates all of the directives that are set on all of your interfaces. So here we see ETH0's hardware address, its type, its net mask, its IP, and various settings. We see a list of hosts, DNS information ascertained from etcresolve.conf, and basically the runtime environment of networking on this system. You may also set directives using the command version of the utility. But how about just plain system config network? This utility brings up a GUI environment like what we're seeing here that has been within the Red Hat environment for a long time. It's a very simple utility. Not as complex or as friendly as YaST within SUSE Linux, but it's useful nonetheless. It displays the devices that are attached to the system, such as ETH0. It tells you the status, its type, its nickname, which doesn't have to be whatever the operating system assigns. There's a hardware tab which reveals information about the interface. You double-click on it, it tells you the assigned alias and any other settings that are applicable, and you even have the option here to set those resources, such as a desired interrupt, memory, items that are self-configuring nowadays anyway. You could even reassign the device to a different ETH value, such as ETH1, and so on. There's a tab for IPsec. It's supported by the kernel, which allows you to communicate with IPsec peers. There's a tab for DNS. You can configure primary, secondary, and tertiary, which updates ultimately your etcresolve.conf file. Hosts updates your etc hosts file with entries that are useful for communications. Here we see one for localhost, another one for the fully qualified domain name of the local system, and one from our Debian studies. So this interface, this network configuration interface, allows you the flexibility of updating multiple text files that are used by the networking environment, by the network startup scripts. Now if you want to modify this logical interface, ETH0, double-click on it. It brings up an interface, another GUI, with some key options that can be specified in the appropriate ifconfig-eth text file, in this case ETH0, beneath the network-scripts subdirectory. But one warning is that you try to refrain from using multiple methods to update your networking configuration, because the GUI, as well as the text version of system config network, will update the same text files. So note, either update your net configuration manually from the shell or using the system config network set of tools to avoid losing settings. In other words, you may modify the configuration file which controls ETH0 beneath the network-scripts directory manually, then make a change using the GUI, and then realize that you've lost the changes that you've made manually. So in here we see common settings such as on boot equals yes, or activate device when computer starts. This is equivalent to on boot equals yes, and we can confirm that by navigating to the shell briefly. Let's find a separate window on our local system. And this is on the remote system, so we'll just exit the shell, then navigate to etc sysconfig network-scripts, and we'll just cat the contents of ifconfig-eth0, where you'll find that the device's name is ETH0, and the on boot is set to yes. On boot is set to yes is equivalent to activate device when computer starts. Allow all users to enable and disable the device is equivalent to the user control feature, which defaults to no but can be set to yes to allow non-root users the ability to make changes to the configuration. For example, for those folks using mobile computers who are not logging in as the root user. Enable IPv6 configuration for this interface is disabled by default in this interface. However, it's configured one file up in the network file, so it gets enabled anyway. Networking IPv6 equals yes. This global directive overrides the context or interface context sensitive directive. Whether or not you'd like to obtain your IP using DHCP. If this were set, the static entries that you see here wouldn't be here, and the boot protocol would revert to DHCP as opposed to static. But because our address is assigned statically, as you see below, it's indicated in the ifconfig-eth0 file. If you'd like to set your MTU to some other value, you can do it here. It's set to 1 by default. We see a tab for route. If there are special routes that are to be added through this interface, you can click on Add, and a route file that's tied to this interface will be created in the network-scripts directory. So if there is a subnet or a specific address that you need access to, create a route with the interface, the system-config-network interface, and this will place the item in the network-scripts directory. Hardware device. ETH0 is assigned to this Intel interface. It can be changed, and it's bound to a specific MAC address that's tied to the network card. So this interface allows you to make these types of changes to the interface, but there's nothing that we'd like to change at this particular point. DNS is set to 75.100, but we could add a secondary just to show you how it gets updated from the shell. For example, let's add our 199 box, which currently is not a DNS server, to the mix. We'll go ahead and click on Save. System config network changes are saved. You may want to restart the network and network services for it to take effect. Generally, that's not necessary. From the shell, if you cat the contents of etcresolve.conf, you'll see the new entry for .199. So when you make a change using the GUI tool, it updates different files depending on the change you've made. This is the DNS configuration file, whereas etc hosts, which also gets updated from system config network, is a static list of hosts, including yourself, all updatable using system config network. Now, what about this idea of creating aliases? We like to show this example because it's a way to provide additional IP addresses to your interface. So let's go ahead and indicate that. Sometimes, especially on a web server, you may want to supply your users with multiple means of getting to the server, perhaps for distinct SSL websites. So IPv4 aliases. To configure an alias from the command line so that it's available now at runtime, execute ifconfig. Ifconfig is the primary interface configuration tool. The changes you make with ifconfig will not persist when the system reboots, but the changes that you make will persist so long as networking is running. It's a great way to test settings. So for example, our host currently has an IP of .10. Ifconfig will confirm that. Let's ping 192.168.75.11. It doesn't respond, so we should be safe to assign that alias using ifconfig ETH0. Now when you create an alias, you use colon and an alias number such as 1, followed by, or 0:0, that'll work as well, followed by the IP address that you'd like to assign with optional netmask and other items. So 7511 will be the alias that we assign, and the kernel will make the system and its services available using this alias. We'll go ahead and Control-Shift-V, echo the exit status, and then clear screen and rerun ifconfig, where you'll now see, in addition to the original ETH0, ETH0:1, which is an alias interface, which can be referenced. Now, we don't need to specify broadcast and subnet mask. These values are derived from the primary interface. If we ping, sending 3 packets to 192.168.75.11, we'll see that it responds. We'll give that a try, and there you see it responds accordingly, telling us that .11 is now accessible. How about trying this from a remote system, such as Linux CBT Serve 4, which currently has one IP address configured, .199. We'll ping, sending 3 packets to 192.168.75.11, and it responds. .10 also responds. We may even SSH back to 192.168.75.11, and we'll be forced to accept the public key, authenticate, and gain an SSH session. If you recall earlier when we mentioned using netstat, any service such as SSH, which is bound to all IP addresses, in this case bound to IPv4 and 6 indicated by the colons, then it will pick up the service that is on all IP addresses, including new aliases. So ifconfig serves as a tool for manipulating your interfaces. ifconfig-a dumps all possible interfaces, and ifconfig-help dumps all possible options. You can add aliases as you see fit. The aliases may also be based on a totally different subnet. They need not be the same subnet. So for example, if config ETH0:2 10.168.76.11, for example, assigns a totally different IP address to the same physical interface, which can be accessed from hosts on the same subnet with a similar subnet address prefix. So let's go ahead and assign that locally and echo the exit status. Now let's reset the buffer and rerun ifconfig. We will see, in addition to ETH0, ETH1, ETH2, ETH02, with a totally different IP address of 10.168.76.11, an address we picked out of the sky. Well, 10 we picked because of its RFC 1918 implications. But apart from that, the address is now accessible to any host on the subnet. Or if we have routing properly set up, the router will route traffic back into this 10.168.76.11 address. That's the beauty of creating aliases. Now, insofar as making aliases stick, in the etc networking scripts or network scripts directory beneath sysconfig, you'll need an item, an entry, such as the ifconfig ETH0. So for example, copy ifconfig ETH0 to ifconfig ETH0:1, and then modify the changes, or modify the file to reflect the changes that we've made. So if cfg ETH0:1, it needs to be escaped, and then just change this from what it currently is, .10 to .11. Everything else remains the same. Now when you restart networking, ETH01 will be brought up, but ETH02 will not be brought up. So let's just ensure that we list that note to ensure that aliases persist. Do the following. Copy etc sysconfig network-scripts ifconfig-eth02, the same directory, ifconfig ETH0:1, the name of the interface. Then 2, modify ifconfig ETH0:1 to reflect aliased IP address. Another note, aliases do not work with DHCP interfaces for obvious reasons. When you define an alias, you know exactly what IP addresses you intend to assign to that Ethernet interface. So keep that in mind. So that's a little bit about how interfaces are brought up in the environment. Again, in the network-scripts directory where you find ifconfig-eth0, there are other items. For each type of interface that's defined on your system, if up, when the network service is invoked, will bring that interface up, such as loopback, ETH0, and ETH0:1. Additionally, IPv6 support will be set up if it's enabled. But there's support within the Linux environment, within the kernel and via modules, for other types of protocols, such as PPP, used for dial-up access, which is more and more becoming outdated, IPsec, for setting up VPNs, IPv6, for routes, for downing and upping routes, and other protocols, such as SIT, parallel IP, and that's parallel line IP, networking over a USB interface. There's even a script to detect hot plugging, in particular for laptops, where you may eject or insert a PCMCIe card at will. So there's scripts for everything, and if the kernel detects the interface type, or if you use the networking tool to define that type of interface, an entry will be created. Again, just launch system config network. This brings up the GUI, and from the GUI you can add various interface types using new, for example, which brings up a wizard, which we've yet to show you. The default or first option is to define an Ethernet interface, for which you'll have to select a card or a different Ethernet card, and if you have a driver, you can supply that. And there are other types of connections, ISDN, modem, which will allow support using a PPP interface, token ring, not as common so much nowadays, but you can define it based on a card that may be in your system if Linux has detected it. A wireless connection, again, if you have a wireless card and Linux has detected it, then you can provide wireless support. Otherwise, you'll have to get a driver for the card, as well as a DSL connection. It supports XDSL, that is the Linux kernel, so ADSL, SDSL, etc. All supported by the kernel if you have the appropriate drivers and support for the hardware. It also supports PPPoE. Notice this time when we launched System Config Network, the alias interface was brought up because of the file that we created. So had we defined an alias interface using the wizard, it would have done the reverse, which is to create a file. And if you double click on this Ethernet interface, you'll see its nickname is :1 with similar settings. So you can define aliases from the GUI tool as well. Just navigate through, bind it to the loan card, give it an address such as 192.168.75.12, the next IP up, set a subnet mask that's sensible, an optional default gateway. By optional, we mean just that. Otherwise, the interface will default to the default gateway. And then this will set it to ETH01 as the next one, or if we want, we can indicate a nickname to set it to ETH02, or cancel altogether. By default, the GUI attempts to use the next logical device. So if we click on apply, it will make a new device, ETH0:1, which conflicts with our previous device. So now you need to determine which one's legit and up it or down it. Let's remove our old device. We'll just get rid of it altogether. And as for the profile, we don't want to delete the whole profile. We'll get rid of ETH0:1, the old one that we define, close the box, and then examine the contents of network-scripts where we see ifconfig. We should have a cat in our history here somewhere for the new instance. And this instance, as you can see, is .12 with user control set to no, which means you must be root to make changes. So again, that's a little bit about how it brings up the interfaces. That's the kernel in conjunction with the network service, which references, again, etc sysconfig network to determine if support should be provided, and if so, then it navigates into the network-scripts directory and looks for different files to incorporate into the if-up process, brings up those interfaces, and makes them available on your system. So now we have ETH0, ETH02. You can remove this interface as well. If you no longer have a need for it using ifconfig, we should just point that out. ETH0:2 delete, for example, followed by the IP address of the interface, which we listed, let's just ifconfig again, as 10.168.76.11, and optionally by specifying the net mask, but this will remove the interface, the virtual interface or subinterface. Now we've got only ETH0 and loopback adapter. Let's just note that as well. Ifconfig ETH0:2 delete followed by the IP address that we had assigned to the interface removes the virtual interface. So you know how to add IP addresses, how to configure interface. This configuration is generally performed during installation, but if you need to provide additional configuration once the system's up and running, supposing you've inserted a new network card or just want an alias interface, then launch the system configuration tool for networking. We did mention that the system configuration tool for networking is available as a text user interface as well. Execute system config network dash and just tab it out to get the TUI interface, text user interface. This brings up a text equivalent which reads the scripts in network-scripts and allows you the flexibility to modify the interfaces or to define a new device altogether. If you press enter on one of the devices, you'll see the properties of the device plus the ability to make the interface DHCP. Once your changes have been committed, the text files will be updated. If you need to define a new device, just navigate to it and press enter, and you get the ability to define Ethernet, modem, and ISDN devices. Enter on add, define your interface, and shortly you'll have an alias interface up and running unless you point it to a different physical interface. Again, all of these items are referenced from the sysconfig and below directories, such as network scripts. The network service, when it starts, reads the items in the network-scripts directory, such as ifconfig eth0, eth0:1, routes-eth0 or routes-eth1 to know how to set up routing, for example, for those interfaces. Now, as far as IPv6 configuration is concerned, if you execute an ifconfig, plain old ifconfig, in addition to IPv4, you see IPv6 configuration information. In fact, we have two IPv6 addresses defined. FE80, and we'll just indicate using : Let's just set up a brief section here, IPv6 config, and we'll list first and foremost as the important feature, it's auto-configured by default gateway, which is usually a router. That's first and foremost. Second, whenever you see an FE80 address, this is a link local address, which is the loopback address. But in addition to being loopback, it can also be used on the local subnet. So it's a loopback/local subnet address. And it's like the automatic IP that's configured with IPv4, the 169 address that we saw in our routing table. FE80 can be used to communicate with other folks on your local subnet. And an address is automatically configured based on FE80 and your MAC address. And that's what we see here with this address. We can communicate with this address and communicate with other folks on the wire using this address. In order to communicate, let's say using ping with IPv6 addresses, use ping6. So for example, ping6 interface ETH0 followed by the FE80 address will do the trick. Let's give that a try, and you need to specify the source interface for this local address. We'll just copy it from our interface here without the prefix, the /64, and this pings using IPv6. Also notice that there's a 2002 address that's configured. This address is automatically configured by our default gateway. It is set up for IPv6, that's the router, the Cisco router, and it propagates the prefixes to the DMZ as well as the internal networks. So as a result, during IPv6 configuration, our interface was auto-configured with this 2002 address, which we configured during the recording of IPv6 Linux CBT edition. So ping6 of this address as well will return useful information. This is a full IPv6 6-to-4 address. So we'll just also note 2002:: is a 6-to-4 address that can be configured based on IPv4 embedded address using hex notation or hex numbers. But again, IPv6 is auto-configured. The subnets and everything are defined on the router on the default gateway, and then the prefix is assigned to the host. The host's MAC address is embedded in the IP version 6 address, whether 6-to-4 or some other address. And you can see it. For example, our interface terminates with 4108. Here we see 4108. And if you go back through the address, you'll see the 02B3 with the embedded FFFE, then 98, then 4108. So IPv6 is auto-configured by default, and there's no need for you to worry about configuring it. In addition to ping6, you've also got traceroute 6. This is used to trace routes on IPv6 networks, whereas ping6 is used to ping IPv6 addresses. There is no netstat6. From the command line, if you simply netstat MTL, you'll see bindings for both IPv6 indicated by the series of colons, as well as a traditional all zeros or an IP version 4 address. So this is an IP version 4 binding. This is an IPv6 binding for SSH. Now that said, we'll continue sprinkling networking throughout the remainder of our studies to shore up and beef up your knowledge on IPv6, IPv4 configuration and implementation within a Red Hat Enterprise environment.